Yes, no problem. Oh, it's probably on that plane from Zoom. Why Indaba amakompyutha amancane impela. Umsebenzi.
Yeah, you want to
I'm an African, and across Africa, when we greet people, they greet you back. Good morning, people. Yeah, that sounds much better. Yeah, in Africa, it is considered rude to not greet someone back when they greet you. So I was starting to get worried about the crowd, but it seems I've got a nice crowd. So today we're getting into the actual policy, Indaba. And just for some background, these were initially planned as 3 separate national climate change policy conferences. So we're supposed to have had 3 gatherings like this. In hindsight, I think I was wrong to merge them. Imagine 3 times the fun we've had. But along the way, some people had some bright ideas and they're like, no, let's merge them into one. And we also thought that the word, conference did not represent the spirit of the uMngeni Resilience Project. As I said yesterday, it's always been about engagement, partnership, co-creation, co-development, co-implementation. So we thought Indaba was a proper word. Let's just have some conversations. Let's get together, talk about what's happened, what's happening, what are the meaningful lessons that can be translated into policy and practice, and how do we do that? We've got a very good range of, participants in the room. Bani yesterday spoke about the science, policy, practice interface. And I think we've got that very well captured in here. We've got, scientists, researchers in the room. We've got policymakers in the room. And we've got, by and large, a lot of practitioners in the room. When I was starting up my career, those 3 groups could never really get together in a room without throwing serious accusations at each other. We, from the research side, would be the first to throw the stone and say, you all don't listen. We've been saying this, for eons. I wrote papers, I said this. If you had read them, you would know. And the practitioners would turn around and say, well, you don't write clearly. Clearly, you need to go back to school and learn how to write. We can't read your stuff. Then they would look at the policymakers and tell them that you guys also don't listen. We are on the ground. We are working with the people. If only you listened to us, we'd be going far together. And the policymakers would look at both the science and the practitioners and say, you guys have no clue what the priorities are. Like, you have no idea. We are dealing with bigger issues. There are bigger issues at stake. And then we'd all go away wondering what those bigger issues at stake were. So I'm very happy that over the years, we've progressed to this kind of space where we get together, we have conversations, we leverage each other's strengths, and we actually deliver. When we work together, we realize impact on the ground. We have a common agenda, which is to improve the lives of people on the ground. We have a common customer, which are the communities in the areas that we serve. So there's much that we have in common than the small differences that we have. I always tell my students that the important thing is be agreed on the destination. You can argue about the mode of transportation. If you want to fly, go by bus, drive yourself, you can have those sort of arguments, and they are good. That is what we refer to as diversity and inclusion. It enriches the process of innovation. So it's good to have that in the same space, but it's good to have a shared vision and agenda. Because if you lack that, then you're fighting about very different things altogether. So you're never going to get anywhere at all. So I'm glad we've gotten to that place where we've got a shared vision and agenda, and we are learning to use our different modes of transport in a complementary way to assist us. So it's pretty much like we are running a marathon, just that some fly part of the journey, some are going to drive, some will go by train, but we are complementing each other, and eventually we are going to get to that destination. So those are the sort of conversations we are hoping to engage in today and partly tomorrow. And it would be good if we all bring our opinions. There is no greater or lesser opinion. There is no right or bad thinking. The other thing that I always challenge my students when we are engaging, I always ask them, what if everyone is right? Then what do we do? Because you know, when you're debating, you always think that there must be the right and the wrong. But what if everyone is right? And that is the truth when you get into the science policy practice interface, that we are all actually right. But what we need is to find that place of compromise where we bring those different truths into one space and do one thing. So hopefully we get to that destination over the next 1.5 days. Okay. So we'll get started with the program. And that was not the welcome and purpose. Don't confuse the two. Those are the ramblings of a professor. We must always ramble. That's what we do for a living. So we're going to get into the program of the day. You actually get the proper welcome and purpose. And to give us that welcome and purpose, I will invite Ms. Kamel Mbizo, the head of branch at SANBI. Thank you very much, Kamel.
Good morning, everybody. What TAFATSWA refers to as the ramblings of a professor, I don't think I can beat that. You put the purpose and the welcome so well, TAFATSWA, so I'll just kind of repeat what you said. But I think you very nicely spoke about why we're here today. Many of us had the opportunity to be part of the gala dinner last night. And that was our opportunity to say thank you and to appreciate all the different contributions and the roles that people have played over the last 8 to 10 years in bringing us to the point where we are today. So you know, often we get stuck into the work, and when we finish a project, we already, you know, thinking about the next project, or else our focus is on the next challenge. And it was so nice last night to pause and reflect and to say thank you, you know, and celebrate, you know, the individuals who have given so much to this project over the many years. I was also fortunate, and I think many of you also were, to be part of one of the field trips. And on the one that I went on, what I found really, really gratifying was we were all standing around owning the project. It wasn't us coming to visit a field site. It was all of us, you know, talking collectively about the challenges and, you know, recognizing them and saying, you know, so what do we do about this? So it was no looking to someone else to solve the problems. And I think what also was very interesting for me that just brought it home was the sustainability of the initiatives. How do we ensure that we build and things don't just, you know, fall back to what they used to be? And the exciting thing for me is that we do have the opportunity, when we're talking about scaling up to a national level, I think it'll be really exciting today and tomorrow to talk about what do we actually mean about the scaling up to national level and building on what we've achieved here. But we have the exciting opportunity now through the Green Climate Fund to see how we can take all this important work forward and have a national impact. So I think exciting 2 days ahead of us. And just, I know I'll be repeating some of the things from last night. Many of you have heard about it, but just a little bit of context for the uMngeni Resilience Project. Let me just repeat the warm welcome that KwaZulu gave, you know, to those of you from the uMgungundlovu district, to those who have traveled from within KwaZulu-Natal, and also those that have come across the country. And then also, I'm told we also have colleagues listening online. Is that right, KwaZulu? So a very warm welcome to all of you. We get the opportunity now in this Indaba to kind of relax. We've gotten rid of the ties and the suits, and we can now roll up our sleeves and really engage with each other. So a very warm welcome to all of you. Just a little bit about, you know, SANBI's role. Something that we've played and we could never have done without the partnerships. KwaZulu, you spoke about the importance of the partnerships. And I think this has been a great demonstration of partnerships. So we've been supporting this project over the last 10 years, because remember, it did start with the whole project design, the proposal development process, which was so critical. And that strong partnership with the district and with the University of KwaZulu-Natal to design and plan. One of the things that came up in our field site yesterday was that important part of planning, that often we cut that short and we don't take the time to really plan well. So yeah, it started initially with the project design and thereafter with the implementation. And through all of this, we've been guided by our mother department. You know, guidance, oversight, Bonnie. Yeah, you know, we always see ourselves as SANBI, as, if I can say, the daughter of the department, but yeah, under the guidance of the department. And then, of course, our gratitude to the Adaptation Fund for the funding to make this possible. We all know, I think everyone here, that overall objective of the project is to reduce the vulnerability of communities and small-scale farmers in this district to the impacts of climate change. I'm not going to repeat in detail. We all know about the devastating floods and the impact that it had. And now we've had the opportunity through the project to see how we can support those vulnerable communities so that they are in a position to adapt. What has also been really exciting for me with this project is what we've been talking about, the science, policy, practice. But to KwaZulu, what's also been very special is the recognition that there's not just one knowledge system. It's not just about the science. We know that we've got multiple evidence bases, our indigenous knowledge, traditional knowledge, what's happening in the communities. So recognizing that there's multiple evidence bases to inform the policy, to inform the planning, to inform the implementation of the project and how we adapt. So I think that's been a really exciting part of the project, and often not always so difficult to get right, you know, when we're doing the science. But I think this project has done really well in taking us forward on that approach. Yeah, so this uMngeni Resilience Project is really the first flagship project when it comes to climate change adaptation. and has really set a great basis for us to move forward with new initiatives, to build on what we've learned through the challenges, working, right from community all the way up to national is not easy. How do we implement so that we actually are strengthening the institutions and coming up with those institutional arrangements to ensure that going forward we do have the sustainability and the impact. So that's also been really, really important. And then I also, alluded to the fact that for me, with our donor projects, we know that there's a time frame. And then the big question is the exit strategy, the sustainability, sustaining what has been started, the processes and so on. But now we have the opportunity to all get involved in the planning and the design of this national scaling up initiative. And I think that's really, really exciting, because it's not now the project's ending and that's the end of it. We really have this opportunity to take all this work forward. So with that, I hope you feel very, very welcome. And we look forward to your active participation today and tomorrow. Thank you very much. Thank you, Program.
Thank you very much, Camille. We'll move on. For the next part of the program, we are going to get a message of support from the Adaptation Fund. I think there's a recorded video. Is it here? Okay, I'll let Christine do her thing.
Dear partners, friends, dear partners and friends of the uMngeni Resilience Project, Ms. Carmel Biswo, CEO of the South African National Biodiversity Institute, Mr. Tlura Maru, Chief Director at Climate Change Adaptation at the Department of Forestry, Fisheries and the Environment, Mr. uMngeni Sithole from the uMgungundlovu District Municipality, Dr. Mandy Barnett, Chief Director
integrating some for several communities, most influenced in the
Apologies to the online. I think there's an echo somewhere. Oh, sorted. Yeah, I was just saying apologies to our participants online. I heard that they could hear the sound from the presentation, but could not see the video itself. So apologies for that. Hopefully we should be able to share all presentations coming from the Indaba, so you get a copy of it. We are going to move on with the program and we'll receive a message of support from the DFFE. Pani. Thank you very much.
Morning, ladies and gentlemen, it's me again. On the program, it says it was supposed to be Mr. Ramaru. Unfortunately, he's on another assignment abroad to make sure that one day we receive more funds to implement such projects. So we had to like split, and cover all bases, so to speak. So thank you. So I'll be giving a message of support on his behalf. And here it goes. It says all protocols are observed to be safe. And the DFFE is delighted to be part of this important project that fostered a collaboration with beneficiaries, municipalities, SANBI, the DFFE, of course, province, as well as the Adaptation Fund. Given this, the project serves as a classic example of how formidable partnerships that are based on people and nature can deliver. This is an embodiment of the New Deal for People and Nature that was adopted at the 15th Conference of the Parties meeting of the Convention on Biological Diversity in Montreal, Canada in December 2022. The Deal for People and Nature is also referred to as the Kunming-Montreal Global Biodiversity Framework. So the DFFE would like to begin by appreciating the work done by SANBI and the University of KwaZulu-Natal in supporting this important project. This project has also demonstrated the importance of partnerships delivering the results that benefit communities. In addition, the involvement of the uMgungundlovu District Municipality ensured that it is implemented at the level of government where the rubber hits the road, as a result contributing to the district development model. Equally important is that the project contributes significantly towards the implementation of the National Climate Change Adaptation Strategy and a framework on climate services. The learnings and experience gained from this project will not only ensure policy formulation, but will strengthen the science policy implementation continuum. The URP is part of the practical implementation of the outcomes of the United Nations Framework Convention on Climate Change negotiations, with funding flowing directly to the communities. But more importantly, the URP places South Africa ahead of many countries in that it has begun to set in motion the implementation of the white paper on biodiversity conservation and sustainable use, and some of the aspects recently adopted as the Kunming-Montreal Global Biodiversity Framework. This is very important given the global interest on the linkages between biodiversity and climate change. This also bodes well with current national initiatives that include the development of an implementation plan for the biodiversity and ecosystems climate change sector response strategy. The latter will build on some outcomes of the URP to enhance the achievement of the desired goals as captured in the National Climate Change Adaptation Strategy. In conclusion, the DFFE would like to express its appreciation of this important partnership and will endeavor to sustain it as far as possible, depending on the availability of resources. Thank you.
Thank you very much, Pani, for the message of support. We'll check the next message from our HOD from uMngungundlovu District Municipality. Mr. Mbongiseni Stole, is he in the room? Oh, he's probably not yet in. Okay, that's fine. When he does arrive, we'll give him an opportunity to say a few words on behalf of the district municipality, who are our hosts this week. So moving on with the program, the next part of the program is our keynote presentation. Remember, I promised you serious science last night at the dinner. So, and I always like to deliver. So we managed to invite Professor Roland Schulze to come and give us a keynote address focusing on climate change, The title of his keynote address is Climate Change. Are we asking the right questions, or are we falling into a climate change trap? Please join me in welcoming Professor Roland Schulze, an Emeritus Professor at the University of KwaZulu-Natal, to come and give us our keynote presentation.
Good morning, folks. While they're setting up, I'd just like to say thank you, Zoom. Thank you, KwaZulu, for the kind invitation through you, Christine, that everything has worked out well. I just need to remind you that somebody like me is a person of vintage. I'm 80 years of age, so if you like what I say, you can think how this guy's got experience. And if you don't like what I say, he's over the hill anyway. Are you ready? Thank you. The other thing by way of introduction is that you're actually jolly lucky, KwaZulu, to have me here, because about 2 years ago, while I was going on my morning jog, still do that, my vintage, I suddenly had great pains. I ended up in hospital with a triple heart bypass, but I'm fine again. However, somebody got it wrong and thought that I had passed on. Oh, sorry. And this was at the 50th anniversary of the Water Research Commission, with whom I've had a long relationship. And so at the beginning of that conference, the CEO stands up and says, "Ladies and gentlemen, I'd like you to stand for a minute's silence in honor of me." One of my colleagues got such a fright because he hadn't heard that I'd died. And so he thinks, well, my cell phone is probably with my son by now. So he phones my cell number and says, "Hello, Mark, that's the name of my son." I answer. And so, "Good morning." And he couldn't believe what he was hearing. He says, "Roland, where the heck are you? In heaven or in heaven or in hell?" Anyway, so much for the introduction. Now for the serious part. KwaZulu has already mentioned the title. Are we asking the right questions, or are we falling into a climate change trap? Now let's see. Which one do I press? That's the vintage showing itself. There we go. Thank you. I'm a hydrologist, and questions that hydrologists ask in terms of nature's footprint are what I call the 5 spheres that we're interested in. We're interested in the atmosphere, the hydrosphere, the phytosphere, the terrosphere, the pedosphere, all these things. And for example, in the landscape, we look at certain issues there: altitude, slope, the riparian buffer zone. In climate, we look at rainfall, the views, the volume, the intensity, and the seasonality and the extreme events. That's the VISE. And we look at temperature, we look at solar radiation, evaporation. We look at soil indicators that are important to us as hydrologists, soil properties. We look at water indicators: base flow, storm flow, peaks, sediment yield, design flood, the 1 in 100-year flood, that type of thing. And under natural vegetation, we are interested in hydrology and where the roots are, what the surface cover is, how much is intercepted when it rains, seasonal water use, and that type of thing. So that's nature's footprint. But we also have questions as hydrologists on the human footprint. And I call these the 7 L's: degradational, residential, agricultural, hydrological, etc. So for residential, we need to look at, is it formal residential, informal, with or without stormwater systems? We need in hydrology to look at dams, water supply, demand, wastewater treatment works, interbasin transfers, irrigation, hydropower, environmental flows, return flows. We look at agriculture, commercial subsistence, livestock, forestry. How does all this affect water? And we look at infrastructure. How does that affect water? We look at industry, light and heavy industry. What does that do to our water? We look at degradational indicators, overgrazing, sheet erosion, downhill plowing, gully erosion. These are issues that all affect the water. And then we look at the environmental indicators, terrestrial and ecosystems, aquatic ecosystems. That is my field of study. Now, let's have a look at climate change. We need to ask questions of the bigger picture. We're emitting huge amounts of CO2 and other greenhouse gases into the atmosphere. Some of you flew here, you've been, you were part of it. And the result is that over the past 10,000 years, if we look at CO2 or methane or nitrous oxide, we've had quite a steady go over the past 10 years, but in the last 150 years, that's what's happening. And here is a blow up of that. That is internationally. And if we look at South Africa, here we are in South Africa. These are measurements at Cape Point there, measurements of CO2, of methane, of nitrous oxide. We're part of this. And you know that the world's atmosphere is so virile and so volatile that something that happens in Greenland, we pick up atmospherically within weeks and measure it. And this is our temperature trend. It's, oops, sorry, it's going up. Where are we? There we go. Okay, that's the result. Now, what we need to do is we need to take nature's footprint and the human footprint and interrelate these, and then put climate change on top of it. Because that's the real world in which we're functioning. The real world is not rainfall, mean annual rainfall is going to increase by 3% or 10%. This is the real world. And to answer these questions, we've got to look, first of all, nationally. So nationally, what we have done in hydrology, we've divided the country up into homogeneous zones, homogeneous response zones. We call them quinary catchments. There are 5,800 of these. And for each of them, we have 50 years of daily rainfall, of temperature, of potential evaporation, of climate change impacts. So each of these 5,800 quinaries has a unique climate, and they're hydrologically interconnected until the water flows, most of the water flows into the ocean. That's the way we have allocated the flow patterns. But we don't only want to look at things nationally, we need to look at things locally, where the impact of land use plays a big role. So in each of these 5,800 quinaries, we've subdivided them further into what we call hydrological response units, or HRUs. And so we can model individual land uses and their individual impacts on a very small scale and then scale up. What the Department of Water Affairs is doing at quaternary catchments, we're missing the point. Just to show you from Kwakwa in the Eastern Free State, how we the 6 hydrological response units are. There's natural vegetation, there's informal urbanization, there are wetlands, there's degradation, formal urbanization, agriculture. This is then what we look at. What is climate change going to do to each of these? And how is it going to impact downstream? Now, to answer these questions, we need tools of the trade. And one of the tools of the trade is climate models. And these climate models have to be what we call bias corrected. And these are the climate models we use. These are relatively recent climate models. And we look at a business as usual scenario into the future, looking at the present, the immediate future, and a more distant future. A second tool of the trade is, as a hydrologist, I need to model these impacts. So I have to use a model. We use a model called the ACRU model. It's a daily time step model, process-based. It's got local backup. It's a multi-purpose model. And we've done a lot of verifications internationally, whether the model is working well or not. So here are some of the components of the model. We can generate base flows. We can generate storm flows. We can generate peak discharges, which is what the engineer wants to know. We can generate sediment yield off a catchment, depending on the land use. Now, ladies and gentlemen, when we do climate change research, are we asking the right questions on the validity of our results, on the confidence of our results? How good are these climate models actually? So we've done a lot of work on that. And here is an example where we have used a 30-year period using historical data. That's the top left map, and using the average of our 6 climate change models, general circulation models. You can see the maps look relatively similar, and the graph at the bottom shows that we're actually on the right track. We can use with some confidence these corrected climate models. But we are not confident in everything we do. So if you look at the maps on the left, and we have a confidence index, a statistic, confidence statistic, you can see that we are very confident when we look at the changes in potential evaporation. Now, the darker the color, the less confident we are. We're slightly less confident with rainfall and with actual evaporation. And eventually we are least confident when we look at groundwater drainage, because in each of these cases, things become more complicated when the rain falls. So we have to be transparent and honest and say, I am more confident in this than I am with that. And that is after I've used 6 models, because each model is slightly different and some strengths and other weaknesses. So please note there is a hierarchy of diminishing confidence. And unfortunately, it's diminishing confidence with the importance in water resources. Runoff is more important than rainfall to us, but we have less confidence in it when we project into the future. Okay, last year in April, we had huge floods in the KZN coastal areas. And are we sometimes, this is my question to you, are we sometimes falling into a climate change trap where particularly the politicians conveniently blame any disaster we have on climate change? And often they display ignorance. They often conveniently forget our history. And let me just show you what I mean by that. We had severe floods. There's no doubt about it. There you can see one day, 300 millimeters over 2 days, nearly 360 millimeters over 3 days, over 400 millimeters at these various places. Our soils, by the time we reached the 3rd day, were already saturated. We had major damage. You can see some statistics there. People displaced, people left homeless, schools damaged, lives lost. And 6 weeks later, we had another relatively major event. It was indeed a major flood event. But the question, was it climate change? Well, let's have a look at the damages. The damages are severe. So did climate change actually play a role? Well, if you listen to government, starting with the state president, this is a citation. This disaster is part of climate change. It is telling us that climate change is serious. It is here. A KZN government official said, it's climate change. It's one of the darkest moments in the history of KZN. And the head of the Institute of Security Studies, who happens to be the ex-CEO of the Water Research Commission, made this statement. These April 22 flood events are the expression of climate change in the form of frequent, high-intensity extreme events. By the way, it was very low intense rainfall. Okay. And also, he stated these floods are arguably one of the most visible and deadly signs of climate change in the country to date. Now, why are people making these statements? Are they conveniently jumping onto the climate change bandwagon? They blame climate change on a lot of things. I see some of you are taking notes and photographs. You're welcome to have the entire presentation later. Okay. Are they using climate change for political expediency, for point scoring? Are they hiding the shortcomings of their own governance or their own capabilities? Or are we just forgetting history? So I dug around a little bit in the history. But before that, what did the climate scientists say? The Weather Service experts said this cut-off flow system could not, with any quantifiable precision, be attributed to climate change. And the intelligent lay people said, this is part of natural occurrence. It's not an aberration. We can't ascribe this to climate change. So we have different views. So let's have a look at our history. We've had major floods in KZN, as you can see from some of these pictures. So I'm just going to go and give you some examples. Dating back to the 1850s, when rainfall measurements started in Durban, in fact, here, 370 millimeters over 3 days. A year later, 303, 695 millimeters over 3 days. That puts our floods, pales them into insignificance. We had in August 63, 420 millimeters over Durban. 3 years later, 390 millimeters. And 2 years after that, at the bottom there, 400 millimeters over 3 days. Remember, we had a little less. And some more statistics coming from various, what I call anecdotal evidences. In 1905, in May, you can see there 580 millimeters over Durban in 3 days. A storm of this magnitude was unprecedented at the time, and so forth. Some more statistics. I'm coming closer and closer in history. 1911, 400 millimeters. 1917, 556 millimeters over 2 days. Makes our present flood pale into insignificance. 1917, 1923, 1925, and so forth. What am I doing? I'm digging up history, things that have happened, far worse than we experienced last year. 1940 on May 5, 590 millimeters in 1 day, not over 3 days, in 1 day, measured, etc., etc. Then we come to the big floods. Des Moines, some of you may remember the flood Des Moines, 934 millimeters over 3 days in Zululand. And the really excellent research was done by the Department of Water and Sanitation on this particular flood. And 2 weeks later, we had 480 millimeters. And then in 87, again, 924 millimeters over 4 days, etc., etc. What am I trying to show you? I'm trying to show you that if I dig around a little bit in history and I look at the 1 day events and where they happened, and the 2 day events and the 3 day events, our floods were severe, our rainfall was severe, but they did in the top 10 of what we have measured in KZN. And now, 14 months later, we still have many people who are affected by not being housed. By the way, how do our South African floods match up internationally? You can see the biggest flood we've ever had, Des Moines, is ranked at 102 worldwide. So there are many places where they've had major floods well in excess to what we have. So why then did we have the consequences of our April 22 flood events? And why were these consequences so dire when we compare them with historical events? Well, number one, We have a lot more formal urbanization. Formal urbanization has impervious areas, it runs off. We between the city engineers department and traditional governance. This is not me, this is somebody else saying this. We have a lack of control of where we build. We have in-migrants, we have homes on floodplains. Folks, God made a floodplain to be flooded, full stop. Okay, otherwise it wouldn't be a floodplain. We have houses on steep slopes. We have a lot of alien riparian vegetation, which is easily ripped out by a flood and exposes riverbanks. This is from the Jeff Tooley from the City Engineers Department in Durban. We have siltation of culverts. Why? Because we're a throwaway society. We have multicellular culverts. Okay, that is an engineering problem we have learned from now. And we have aging infrastructure, which is not well looked after very often. So what can we then do? Remember, my thesis is we've had worse before. What can we do to mitigate? This is an adaptation conference. What to mitigate against such flooding? Well, on the one hand, we can provide engineering solutions, constructing bigger culverts, separating debris walls. On the other hand, we can provide environmental solutions, removing alien vegetation, preventing upstream siltation. And the summary there, which you can read in your own time, is from the City Engineers Department in Durban. We can thirdly provide socio-economic solutions. So let's just go back. We've had engineering solutions, we have environmental solutions, we have socio-economic solutions. Why don't we simply prevent why don't we have proper solid waste disposal? Why do we have illegal construction within the 100-year flood zone, which again is there because it will be flooded? And then we have scientific solutions. We need to relook our science of extreme events. We look at the factors causing climate. Is it climate change? Will we have more frequent and more intense of these events? We've got to develop smart early warning systems. So that was my one section of the talk. Are we forgetting history? And we are. Now back to my other thesis, are we asking the right questions in terms of climate change? What is the more I call it the more progressive real world of decision makers want to know? The pick and pays of this world, the macadamia industry of this world, etc., etc. What are the things that practitioners like myself, I used to be an academic, I'm not a practitioner, okay? What are people like myself being kept busy with? And by the way, I'm not looking for work, but the work looks for me. Okay, and my thesis here is we need to look at the derivatives of climate change, not just what is the change in mean annual rainfall and what is the change in mean annual temperature. That's child's play. It's the derivatives, and I'll give you some examples. I'm going to show you 5 examples from work I have been involved in. Four of these examples, very recent work. Tshwane Municipality, the City Engineers Department in Tshwane. You won't believe this with Hammanskraal at the moment, but they are very, very smart in the City Engineers Department, not the people who are throwing away things. And here's a report we did for them on storm and wastewater infrastructure design under climate change. So that's the area we're dealing with. By the way, Tshwane covers 4 provinces in South Africa, interestingly enough. This is now our flow configuration. We're hydrologists, we make water flow. And the red dots there are the wastewater treatment works. We often forget the role of a wastewater treatment works when we do our hydrology. Day and night, a steady flow of water comes out of a wastewater treatment works. It changes the local hydrology completely. I haven't seen a single publication in Water Affairs and elsewhere that actually factors that in. Then we look at land use. This is the natural vegetation of the Tswana area, and this is the actual land use. And if we just take a tiny area, you can see how complex the land use is. And each of these land uses has a different response to climate. So in real life, we deal with complex actual present land uses. And we need to look and consult with the city engineers department. What are their plans for future land use? Climate change is something into the future. When I build a bridge or a culvert, I build it to last 30 or 40 or 50 years. So I've got to look at future land use. And so when we look at our climate change inputs and outputs in Tswana, we've got to first ask ourselves how trustworthy they are. And I'm not going to go into the scientific detail here, but our models are doing a pretty good job in this particular area. And if we look at changes in mean annual rainfall with climate change, here is what we project for Tswana. And if we look at changes in stream flow, the patterns are much more complex. And so they want to know how to design stormwater systems in future. So we've got to look at this from a baseline perspective. Baseline is our natural vegetation. What is our natural vegetation giving us in terms of floods? Then we look at current urban land uses and what does that do? And we look at their projections for land uses and what does that do? So we have the blue and the brown and the gray ring. And this next one will show much more clearly here that apologies. There we go. This one will show a lot more clearly that with our projected land use, future urbanization, our 100-year flood is a lot bigger than it is at the moment with present land use, and that is a lot bigger than if it were natural vegetation. So quite often we forget the human footprint when we look at climate change. And these are the issues we need to address. And then we've got to ask ourselves, what are the implications of all of this for adaptation? The second case study I'd like to share with you is one we did for a government department for environmental affairs and for rural development in 3 district municipalities of South Africa, which are very different. Here you are. On the left, John Taola in the dry area, then the Waterberg in green, and uMngungundlovu in blue, and some of the characteristics. So how does climate change impact in different regions of South Africa? So we developed a series of steps. The first step is, let's identify the key sectors that are related to climate change: water, agriculture, biodiversity, infrastructure and settlements, health, hazards, and in the case of the uMngungundlovu, coastal influences. Secondly, within each of these, what are the critical issues? So in water, it's surface water, groundwater, the complexities of sharing water. In agriculture, it's dry land, irrigated, and so forth. Thirdly, we identified what the key drivers are of climate change. Direct drivers like temperature, and direct drivers like rainfall, and derived drivers such as frost and heat units and chill units, and many, many more. And then fourthly, we asked ourselves, well, how different are the responses? What do we imply by this, that, and the other? What do our maps show? Who is at risk? Who is vulnerable in the various activities? And then how can we adapt in terms of resources, new science, technology, policy, social capital, and changes in land use? And so we identify at risk for which we may need to do adaptation. I'm not going to go through these, but you can see from national water planners, to municipalities, to wildlife and game reserves, to the insurance industry and heavy industry and the tourism industry, and formal settlements, poor communities, etc., etc. These are the issues we need to address when we look at adaptation from my field, which is water, and for many of your fields, this will be similar. So we then considered the following in regard to climate change indicators. What is the magnitude of change? In other words, how much is the change? Is it up or down? In which season does it happen? How rapidly is it happening? Where is it happening? How confident are we? What can we do to adapt? And is the system important? Should we worry or should we not worry about it? So these are the questions we asked. And I'm just going to take out of a big report a couple of key issues we looked at. Oh, there we go. For example, if we look at the change in groundwater recharge from the present into the future, those are the in the driest year in 10. You can see the three districts have similar but slightly different changes in a dry year. But at the bottom, in a wet year, it is a lot worse. But what I'm trying to tell you is we can't just make a simple statement. We can't just make a simple statement, in South Africa, this is likely to happen. You can see how this is very locality dependent with the local climate. And then we now look at these 29 sectors, and in red we have what I call losers, and in blue we have the winners. And where should we be looking to adapt, and how should we adapt, and what is the impact? So I'm not going to go through all of this. Those of you who are interested, you can have a look at this or even get the whole report. And I therefore have to ask myself three questions. What's common? What's different? And what have I learned? And, groundwater recharge, if you look at the top left-hand map, about 1/7 of South Africa is what we call endorheic. Endorheic means the drainage is internal. It doesn't go into a river and flow into the sea. How do we model that? It's never been done before in South Africa. So, and let alone having to do it with climate change. So the bottom map there, that's the Waterberg, just to show you some work we did for Eskom when Eskom still was a 5-letter word. Yes, yeah. And yeah, so sorry. And we could have a look at what climate change would do in this particular instance. Now, I'm switching from water to farming. Because many of you here are small-scale farmers or deal with small-scale farmers. What does heat stress do to cattle, and how do we model it? Well, I'm not going to go through that whole thing, but to say that heat stress decreases reproduction and decreases production of milk with various formulae, which are given there. Oh, there we go. So if we then map the heat stress and look at the number of days when the cattle are in an emergency state, you can see what happens at the top, and at the bottom you can see how this changes into the future. So these are what we call real issues of climate change. And they are, in this case, only losers. Commercial livestock, subsistence livestock, wildlife, poor rural communities, they are the losers in climate change as far as heat stress in cattle are concerned. Again, what's common, what's different, what are we learning? Fire. There's Mr. Fire. We have a quite complex model for fire in which we take into account some of the things at the top are hidden, But we take into account maximum temperature of the day, the minimum humidity of the day, the wind, the biomass, is the soil wet, and put that in a fire model. And you can see at the top there the percentage of days on which fire is very likely, and the three patterns are very different. Okay, this is the real world. And at the bottom, we can see the change into the future. And again, they are different. This is the real world that we are dealing with. What's common? What's different? What are we learning? Malaria. I'm not a medic. I'm a hydrologist. I have a daughter who's a medic. But here are 4 indicators, malaria indicators related to temperature. And we then went and had a look at these in the 3 areas. And what you can see here is under present conditions and under future conditions. You can see it gets redder here, it gets browner, it gets worse for these various indicators. That is for the Waterberg, and here it is for John Tahola and for Mkanyakuda in Zululand. So these are, to me, real issues of climate change. And again, most of the sectors that are affected by this are in the red zone. In other words, they are losers. It's getting worse. What's common? What's different? What are we learning? I don't have time to go through all of these things. Alien invasive plants. Here are some types of alien invasive plants and maps of alien invasive plants in some of the various areas. And these are, on the left there, these are the sectors that are affected by alien plants and reduced water availability, costs of eradication. These are all reds, these are all losers. But look at the bottom there. It's a source of firewood for some people. So we have winners and losers in this. What's common, what's different, what are we learning? That was my second case study. The third case study deals with macadamias, macadamia nuts. SAMAC is the South African Macadamia Commission. And you can see from the graph there that macadamia production is on the increase in South Africa. Now, the easy way out, if the macadamia industry asks us what's climate change going to do, the easy way out is to say, okay, here is a map of Köppen climate zones. This is a zonation of climates, and 1, 2, 3, 4, 5 of these climates in this particular area are climates that are relatively ideal for macadamias, and this is what it changes to into the future. That's the easy way out. Growth periods. This particular series of maps shows the growth period from growth to the hardening of the map. And we look at historical, the ideal is this orange here, and how it's changed 15 years from now, 20 years from now. If you plant a macadamia tree, it's going to bear fruit for 30 years. So you've got to think 30 years ahead. It's not like mealies, which you reap at the end of this year. So these are some of the issues that we deal with. But then the macadamia industry thinks they want even smarter answers. They need, for certain growth of macadamias, 3 contiguous hours in July that are below freezing. So we need to convert daily into hourly temperatures and have a look now and into the future. They also want to know in the month of October, one of the sicknesses that the macadamias get is called dry flower. How does it change? Or green mold, how does it change? Or husk rot. These are all the real issues of a macadamia farmer. How do these change? The fourth case study I'd like to share with you very briefly is from KwaZulu-Natal. KwaZulu-Natal is that, I beg your pardon. There we go. Oh, that's uMacadamia we've done, sorry. There we go. KwaZulu-Natal is in the Eastern Free State, that little dot. It used to be the smallest of the homelands. And you can see there mountains in the background, the Drakensberg. The graph shows you that the rainfall altitude relationships are very complex in these mountainous areas. And there's a huge amount of peri-urban development there. And it's a cold area too. Now, forget about the complexities of these graphs. Look at the color coding. I'm looking at the impacts of climate change on design rainfall. That's the 1 in 10-year rain or the 1 in 50-year rain. Let's look at the yellow things. The relationship between the 1 in 50-year rain and the 1 in 2-year rain is that the 1 in 50-year rain is twice as much, but the 1 in 50-year flood is 3 times as much. I'm amplifying when I convert rainfall into runoff. We look at the extreme rains. When it rains here or there, it rains locally. But remember, stream flow goes from uphill and upslope to downhill. So this is something that is local. Extreme rains, extreme floods increase downstream. And with design rainfalls into the future, our projections here show that the rain is going to, extreme rains are going to increase by about 10 to 15%, but the extreme floods by 15 to 35%. Again, we have 2 issues that are important. One is what I call the amplification of extreme floods over extreme rains. Rainfall is one thing. Runoff, any change in rainfall is 3 times or twice the change in runoff. And the second thing is, which I've stressed already, rain falls at a location, runoff flows away. So these are issues that we need to look at in KwaZulu-Natal. But what about the actual land use in this particular area? You can see here a general land use map, and if you take a tiny area like that and blow it up, it's quite complicated. And so we subdivided the area into 19 different zones. The ones with red are the ones where our colleagues at the University of Free State are doing water quality and monitoring for a Water Research Commission project. And then we look at the different land uses and how they affect runoff and change. So at the bottom there, bare soil and eroded areas have a considerable impact on runoff. Formal areas have some impact and informal areas little. And if I express this slightly differently, what I call the multiplier effect of going from natural vegetation to erosion is that I get locally 3 times the runoff. And in the formal urban areas with tarred roads and so forth, I get twice the runoff that natural vegetation would have given me, and informally 1.4 times. These are issues that the planners need to look into, and they need to then project land uses into the future. And if we look at some spatial impacts, storm flows, the top map there shows storm flows under natural land, under natural vegetation, and here under actual land uses, it's the same scale, and the actual land uses have a lot more storm flow. They considerably increase local flows. And if we put climate change on top of that, the storm flows are somewhat higher with actual land use than with natural vegetation, but not as high. And the point I'm making here is that land use impacts often have a much bigger impact than climate change impacts, especially locally. And we forget that. When we do when Water Affairs does its designs, they look at quaternary catchments, and the land use impacts are totally diminished. You can't see them. Lastly, and I'm coming to the end, what I call our forgotten cousin. We deal with climate change and air temperature. What we forget is climate change and water temperature. And in 2010, Kurt Barachivi and I did some work on climate change and water temperature in the Tugela catchment. We couldn't go beyond that because we simply didn't have the resources. But you can see in the top map, blue is cool water. You can see the cool water there in the Drakensberg. Red is the warm water, but you can see here when it mixes, it's still relatively cool. But look at the future. Where's the blue? It's all gone red. So we've got to ask ourselves, what does water temperature, our forgotten cousin, what does water temperature do to aquatic habitats, to bilharzia, malaria, to power cooling, to wastewater treatment works? And so, folks, just a few final take-home questions. We already have a severe climate, but we must be careful that we don't jump onto the climate change bandwagon too quickly. Maybe for political point scoring, maybe to hide our own inefficiencies, or because we forget history. Not everything that is a disaster is climate change. Okay. Secondly, I think we should move away from a primarily statistical approach in climate change to a more attributional approach. What are the causes? Why? What are the effects? That's attributional causes. I think we need to address the derivatives of precipitation and temperature, not just mean annual rainfall and mean annual temperature. They mean nothing. It's the derivatives, the extremes, the thresholds, and so forth. We need to move into what I call the space of real people with real problems in the real world of real locations in South Africa. That is where we need to be headed. And I think the uMngeni Resilience Project has been doing that. And then we often see these maps of climate change to 2100. Folks, we don't know what's going to happen in the next 30 years. We've just had COVID. We've had energy changes. We've had tensions in Ukraine. All of these things also change the climate change into the future. So projecting to 2050, no problem. Projecting to 2100, I wash my hands. There are too many things we do not know yet. I forgot to put artificial intelligence in here. What is that going to do? Okay, and then we need to not research, we need to research, to look again. There we go. That's the way we should be spelling research. Research, look again. Using the latest climate change models, doing proper bias correction, and looking at perhaps the effects of COVID and energy and so forth. And so to the end, have a look at that reserve for drunk drivers. At the end of the day, ladies and gentlemen, I think we need a sober analysis when we look at climate change.
I think there's a small gift for you, Prof.
Thank you very much. Much appreciated.
Yeah, thank you very much. Okay, I hope that was as interesting to everyone as it was to me, and the lessons that Roland was sharing. I think I mentioned yesterday about the floods last year in April. And I remember it flooded. I was coming from Nepal and I just landed when it was flooding. And the first phone calls I received were from, it was the SABC, ENCA, and a couple of media houses. And everyone wanted me to say climate change. And I had to keep arguing and reminding them that without proper attribution studies, we cannot at this moment say, it was climate change. It was a cut-off law system, which is typical weather system in that area. There was an interview on SABC where they were saying the worst floods in history. And, and again, one was at pains to remind them that these are not the worst floods in history. It's maybe the impact and also the time we're living in that information moves faster. So we are more informed about things and we can see them in real time. But I'm really glad you came in quite strongly with the science to really show, especially the part about our footprint as people, the changes that we have made to the landscapes within which we live, and the impacts it is now having in terms of exacerbating the disaster part of what would be a natural hazard. And the URP has made significant investments in terms of addressing that human part. I think some of you were in Vulindlela yesterday for a field trip. And for myself, those remain some of the hardest URP investments to defend, because people like to see things. People like to take things home. So no one could take anything home in terms of the work that was done in Vulindlela. No offense to anyone, but there was nothing to cut a ribbon. So there was nothing ceremonious. When they were putting those blankets, fixing the gullies and so forth, there was nothing wow that you could bring people and say, look what has been done here, look at the landscape. So such investments in ecological infrastructure are always very difficult to motivate and justify and even defend afterwards. I'm always worried about the terminal evaluation, but when they come, I don't know where I'll be pointing. Somewhere like over there. Yeah, it's different from taking them. Those who were at Swaimani High, they got there, they saw the lightning, warning system, it had lights flashing. They're like, oh yeah, this is it. We need this. But the important part is, those are the significant investments that we actually need to put, our money into, because people live within landscapes. We are part of landscapes. So if we do not take care of that broader landscape and the environment, there are significant implications for people and people's livelihoods. The farmers that we were seeing yesterday, for them to be able to make a living from agriculture and farming, they have to be located in a healthy and productive landscape where the ecosystem services are functional. There are things that we ignore, such as the role of bees, biodiversity. What does it support? You're growing your plants, they need to be pollinated. If we are busy killing all the insects, killing their habitats, cutting down all the trees and so forth, who's going to pollinate your crops and things like that? So the farmers that you experienced, for them to be as excited as you saw them yesterday, they need a functional landscape to support their activities. The disasters, fire, floods that we are trying to deal with and address, they can be strongly mitigated if the landscape is well managed and functional, and if nature is playing its buffering role. So these things are integrated. And one of the important points to take forward as we scale up the URP is that integrated approach. And and taking it forward in a more holistic and systematic pattern. The other thing that Roland raised indirectly was the issue of trade-offs. Urbanization creates trade-offs. Those trade-offs are through the increase in impervious surfaces, which then generate more runoff. Then we see the implications. But urbanization as an agenda, it is a good intention because cities create employment, people are moving into cities, everyone wants a nice house with access to electricity, reticulated water, and sewage. But if urbanization happens in a manner that is not properly conceptualized in terms of understanding the broader system and the trade-offs, it creates problems, which are what impacted us last time. So when you are talking about, climate sensitive spatial planning, that is what we need. How do we work together with town planners and bring in that aspect to say, how can our cities grow in a manner that does not create trade-offs for sustainability, in a manner that still supports, ecosystem services? How do we ensure that water, we balance the demands for water in terms of growing urban areas and the areas around them that generate runoff that gives water, which you get in our dams and so forth, to sustain the cities? Otherwise, we'll constantly be faced with day zero if we do not look at that from a systematic perspective. So how do we reallocate water from cities back to the environment? Those are the questions that we should be asking ourselves as we move forward. So the scale-ups that we are going to be doing for the URP, we will take the best of what we got in terms of the interventions. We'll take the lessons that we got in terms of the importance of integrated interventions. We'll take the lessons that we got in terms of the need for transformative change and what is transformation and at what level who needs to transform. Does everyone need to transform? We'll take those lessons forward. So thank you very much, Roland, for really, putting the evidence base in a very simplified form. I would have never been able to take the science and simplify it in that manner. They've probably just ended up with some very crazy, confusing graphs. Yeah. Come and see my presentation tomorrow. It will be very intimidating. Yeah, so I have time to take 2 or 3 quick questions for Roland. And before we go for tea break, we are hoping to be able to catch up with our program. And then there'll be a few announcements from Christine before we go into the tea break. I think we'll be splitting into parallel sessions afterwards. Isn't that so, Christine? So she'll announce how we are going to manage the parallel sessions. And then a few corrections from myself as well. Earlier on, we had a presentation from the Adaptation Fund. The representative from the Adaptation Fund made a small error. He referred to our colleague Camille as the CEO of SANBI. I think we all met the CEO of SANBI yesterday. She has, however, previously acted as the CEO of SANBI, hence the honest mistake from our colleague. She is and has always been the head of branch at SANBI and a strong supporter of the URP, and we really appreciate you've always been there throughout for the URP. So that's one minor correction. I thought I would leave it until we had gone through the presentations and so forth. And questions, or everyone wants to drink tea. Mike usually always has a question. He never, and Rashida. So I'll take a question from Mike. Mike, you must have a question. It's unnatural. You're still processing. Roland, you should give me your skills of presenting. Then I'll be able to manage mic in meetings. I'll be sorted. Rashida?
Hi, thank you so much. Thanks a lot, Roland, for the presentation. I really enjoyed it. And especially the part that you were 80. I can't believe that, and I hope and pray that when I'm your age, I'm able to, share information the way you do. Congratulations for the amazing career that you've had, and thank you so much for sharing that with us. So my question is, I think it's both to you and to Fadzwa. So Roland, in your presentation, you mentioned that with climate change modeling, you have to consider a whole suite of human impacts. And Tafadzwa, you also mentioned when you were talking about Vulindlela and that site and all the environmental management work that has been undertaken there, and how difficult it is to motivate for that or to show it's been done. So my question really is, if environmental management is so important to improve resilience of natural capital that also supports climate change and all the other human development impacts that we are wanting to achieve, have you considered, or is there anyone considering that in South Africa, considering modeling positive impacts? So I know that you're modeling negative impacts in terms of human development impacts on the environment and related to climate change, but what about positive impacts of managing natural capital to improve resilience? Is that being considered? Because is there some opportunity space there for us to say that if we implement these activities or these management interventions in these areas, that's where we'll get greatest, benefits or reduce climate change impacts? I think then we can start to focus our basically funding into those avenues and those areas. Thank you.
Thank you. It was a very comprehensive question. I can't just say yes or no. You may have noticed in the 3 district municipalities, which I showed you 4 or 5 examples from, and there's a whole book of it, by the way, if you're interested, that I had the negatives in red and the positives in blue. So I've touched on that, but I think what we need to do, much more than we are at the moment, we need to get physical scientists like myself and economists and human scientists sitting around a table, having a look at one of these maps and saying, what does this really mean? Okay, it's outside my field of expertise, but one needs not just to have us physical scientists around a table, or all the economists or the social scientists. We've got to sit together. Okay, that is very important. That is, in answer to your question, my main message. I haven't done all of that, but we need to do it.
Thank you very much. Second question.
Thank you, Chair. Good morning, all. My name is Abulele Sekwento from the Department of Forestry, Fisheries and the Environment under Knowledge Management. Maybe mine is not a question, but perhaps a comment to the presentation and appreciation of the information that has been shared with us. It kind of reminded me of a short story that I'll be telling, tongue in cheek, maybe just to ease the pressure that we're under. Maybe climate change is not the cause or the reason for all the disasters that we're having. And the information that you've shared with us in your presentation certainly points that direction, that maybe we should consider a rigorous effort in doing climate change education to raise awareness of what it really is and get the right message across to the entire country. Just after the COVID-19 regulations were lifted, I attended a traditional do in rural Eastern Cape, one of the first that were allowed. And it was a weekend after, intense rainfall had taken place. For some of us who don't know how to even, categorize a flood, I would say that was a flood. And sitting there enjoying the meeting, that event, speaking to the elders, they said, no, it's God cleansing South Africa of the effects of COVID-19 and all the bloodshed. That was late 2021. 2022, it so happened the floods in April took place, and I visited again and we started talking about this, they said, you see, God has a way of taking care of his world. He was cleansing. So I want to say I'm seeing a historical trend there. It could be going to another province and there's more cleansing, meaning that after that clean slate, the country has a great future ahead for us to, plan better and do things in a better way. So maybe it's not even political dodging responsibility. There are better days to come. There's a silver lining at the end of all of this. Thank you.
Thank you, Roland, and thanks for the vast experience we have had. And I was saying my question is related to what the previous speaker was saying. I liked the chronology that you are giving, what has been happening since 18-something, 16-something, up to now. There are even worse disasters that took place even before people like we were even born. In China, 1.2 million people died because of a flood. So can we say this climate change, are we falling, I want to go back to your title, are we falling into the trap of climate change? Is it something that is happening naturally, or it's part of the evolution that needs to happen? What's actually happening? Are we to blame for what is happening?
Thank you. Can you hear me?
Yeah.
Can you hear me? Yeah. Climate change is real. Okay. There is no doubt about it. We are measuring it in broad terms like changes in temperature and so forth. But we cannot attribute everything to climate change. That's the one thing. And the other thing is we've got to get to what I call real people with real problems in real locations. That is very important in our climate change issues. And secondly, we've got to look at what I call the derivatives of temperature, heat units, maybe chill units, maybe this, maybe that, and the derivatives of rainfall, the 1 in a 100-year flood and that type of thing. So we need to look at beyond what most people express as climate change. The rainfall is changing, the runoff is changing. Those are what I call motherhood statements, okay? My mother said, they don't mean much scientifically. So we've got to delve into the real thing. And thank goodness you hear from the Water Research Commission. But before your time, when we did the work on water temperature, that is a crucial issue. And on numerous occasions, the WRC has said, thanks, but no thanks. We are missing the point in some very, very important issues. And so we've got to sit around the table and say, okay, if the rainfall is changing and the temperature is changing, what does it really mean? And we've got progressive, in South Africa, we have progressive city engineers departments. Durban is one, by the way, where the flood happened. Their city engineers department, 8 years ago already, we did climate change assessments for them to reorganize, to change the wastewater treatment works and all sorts of other things. The macadamia industry is another, very progressive, but we seem to forget those things. So we've got to hit the road with real people, real problems in real locations. Thank you.
Morning, my name's Terry Tedder. I'm with the Richmond Fire Protection Association. Roland, thanks for a really comprehensive thing there. So I think in your infinite wisdom at 80, how do we sort this problem out? Because what I've found, and I think it's one of the positives of what we've done with the ERP, is trying to get people together. But what I've in my experience is that a lot of people are still working in silos, and it's to break down those silo walls and work together. And I don't know whether you've got any comment on how we change the mindset of not ticking boxes, but working together so we can really make a positive difference and not just talk about it.
Thank goodness the CEO of the university is not here to listen to what I'm going to say now. But universities are very bad at ticking boxes, and so are government departments. Tick, 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 we've done it. We're going to get some more funds next year. That is not enough. Thank you very much for that comment. We need to sit together. The problem, one of the problems with young scientists, to become recognized, they have to publish. They don't want to publish in the Natal Witness or the Daily News or so. They need to publish in fancy journals, and another 10 people will read that. I want 1,000 people to read it and to understand it. But our systems are actually against us in this particular instance, that we have to do certain things in certain ways to tick certain boxes. But you see, I can say that because I'm past the box ticking stage. Yeah, but thank you.
No, thank you very much, Roland. We can excuse you. But yeah, very relevant questions coming from the room around issues of climate change. We say we are living in the age of the Anthropocene, which is the human age. So usually when we use the phrase climate change, we use it loosely, but it can be differentiated into natural climate change and the anthropogenic, which is the human-induced climate change. That's where you and I are contributing massively in many ways. And we each have a responsibility in that regard to really change our behavior at an individual level. During the COVID period, greenhouse gas emissions went down quite significantly, and the rate of warming also correspondingly so. But since the opening up of the world, it has actually accelerated more than the rate it was moving pre-COVID, because we really came back with a bang. Yeah, everyone came back. We were lonely. We wanted to go somewhere, jump on a plane, go on a holiday, and do things and experience life. So we came back big in terms of polluting and so forth. But it's something that each one of us has to take a personal responsibility around. And usually we talk of decision makers and policy makers as a group that is sitting somewhere who have to make decisions and make policy. So we exclude ourselves from the decision-making process, but we are important decision makers. Society and history will tell you that decision makers are slower than society. Society evolves first and actually regularizes certain things. And then decision makers will take note of what society has made the norm. Then they'll gather around and put in place some regulations and craft a document. But society leads, and then decision makers follow and sort of ratify that. So if we become more conscious and aware of our decisions and choices, for example, a guy like me who contributes significantly because every week I'm flying off somewhere. So I've got a very high footprint because every other week I'm somewhere, raking in the miles. I have a responsibility to start asking people that, do I really need to be there in that meeting? Can I send you a PowerPoint presentation? Is there no one who's locally available there who can talk to these similar issues? Like asking those questions. Or do I still insist that, well, it must be me everywhere? So I'll be on the plane until, the donkeys can talk. So you have to take personal responsibility and actually tell people that I've made a commitment to reduce my greenhouse footprint and I will not be taking any unnecessary travel. Not that your meeting is not important, but I believe I can still contribute remotely. And even at home, in how we manage even our yard and so forth, the plants we grow, be mindful what vegetation are you encouraging in your yard? Is any of it invasive? So each one of us can in a way, you know, I drop off my son and there's a long queue of cars, you know, all parents in line to drop off our kids. We could be carpooling. There's no need for 10 of us with 10 kids to drive 10 cars in the morning, coming from the same place to the same school, all of us to drop off our kids. You know, we could be carpooling. If you're in government, just because you get a higher rate of reimbursement, the bigger the size of your engine. That is not a call to go and buy a big engine. See? Yeah, take some personal sacrifice, but it's not a call to go and buy the biggest engine in town. So take some responsibility. So the point that I'm making is a lot of, you know, the climate change is human induced. And unless we start acting differently and making different choices, you know, people will go to so many COPs and make so many pledges, but it will not change the trajectory. So we have some personal responsibility and behavioral change to undertake. Okay, thank you. I heard that the HOD for uMgungundlovu has arrived. Mr. Stolle, are you in the room? Okay. He's supposed to, you know, just say a few words to welcome us into his district once again. He was not there at the beginning. If you don't mind, Jobe, to just come and, you know, welcome us into your backyard so that we can be free to enjoy ourselves.
Thank you so much, Tafa. My name is uMngungundlovu. I'm the HOD for Economic Development and Planning in uMngungundlovu District Municipality. I would like to greet the Honorable Mayor of Richmond Municipality, who's with us here, Councillor Ngongo, the Chairperson, uMgungundlovu of the Portfolio Committee, the strategic partners, particularly SANBI, UKZN, DFFE delegation, as well as the Adaptation Fund. You are all welcome. I know that I'm late and it's always difficult to speak after the legend has spoken. It's highly appreciated. And as the beneficiary district municipality, we highly appreciate all the work that has been done in our district. And I think the mayor alluded and spoke very well yesterday in his address of our intention as the district to have the project, go even further to be extended to other local municipalities within the district. And the partnership that we're having with our partners, SANBI, UKZN, is highly appreciated. We collectively doing a great job, and the impact on the ground in our communities is clear for everyone to see. The work that is being done is highly appreciated. I understand, colleagues, that there is even more task ahead of us within a very limited space of time up until the projects come to an end at the end of September. But I would like to say that we'll try and push as much as we can to achieve all the objectives that we've set for ourselves up until the projects come to an end. And hopefully, we hope that good initiatives such as this one of URP will be able to be taken further. We had a great opportunity yesterday to interact with the DG, and yeah, there's a lot of things that are promising that are coming on our way as a district. So thank you very much for participating in this magnificent and good session that is going on. And then I hope that everything goes well. Obviously, because I came with a chairperson, I will ask to be excused. She has another commitment somewhere. So we'll leave before the session ends today. But I hope that everything goes well and you participate as you have been participating. Thank you so much, colleagues.
Yeah, so there you can go out and dance. It's official. I'll ask Christine to just come and take us through the next steps before we break for tea.
Hi, everyone. Obviously, we are running a bit late, so we'll start the parallel sessions as soon as everyone's got their tea. If you're attending parallel session 3, that will stay in this venue. So that's so that you know where you're going. And then if you're attending parallel session 2, which is the role of climate information services in disaster risk management, there's a chapel that you would have driven past as you drove in. That's our second venue. So if you're attending that session, that's where you can proceed to after your tea. And then lunch will be at 1 o'clock in the dining room where we served dinner last night, if you were here with us. And just at the other side of that dining room, I just wanted to let you know that there is a small room available. About 10 people can sit there. If you are wanting to have any meetings or discussions coming out of what you're talking about in the various sessions, that's available for your use. But other than that, please enjoy the venue, please enjoy the next sessions and enjoy your tea. Thanks, everyone.